Hello, this video is on functions. On the basic concept of a function, on the use of function notation, and the domain, and the range, and the graph, as shown here in the syllabus. A function is a rule that maps an input value x to a single output value called f of x. You may have called it a function machine in the past. For example, the rule that squares an input value and then adds on 3 would map the value 4 to 19, as 4 squared plus 3 is equal to 19. So a function is simply a calculation on an input value to produce an output value. There are two different forms of function notation. For the rule that squares an input value and then adds on 3, we can either write f of x is equal to x squared plus 3, or f is such that x maps to x squared plus 3. The letter at the front, in this case f, is simply the name of the function. The input value of 4 mapping to 19 can either be written as f of 4 is equal to 19, or f is such that 4 maps to 19. A function can either be one-to-one or many-to-one. A one-to-one function is when the output value is mapped from only one input value, whereas a many-to-one function is when an output value can be mapped from more than one input value. In the example where the function g of x is equal to 2x plus 1, we see that 4 is mapped to 9, or 9 is mapped from 4. So g is a one-to-one function. For the function f of x equal to x squared plus 3, we see that 4 is mapped to 19, and also negative 4 is mapped to 19. So 19 is mapped from 4 and negative 4. So f is a many-to-one function. The domain of a function is the set of all the allowed input values, and the range of a function is the set of all the possible output values. In a mapping diagram, the domain, or the input values, are shown on the left-hand side of the diagram, and the range, or the output values, are shown on the right-hand side of the diagram. Consider the function g of x, where the input values can be 1, 2, 3, or 4. We see an input value of 1 produces an output value of 3. An input value of 2 gives an output value of 5. An input value of 3 gives an output value of 7. And an input value of 4 gives an output value of 9. So if the domain is the numbers 1, 2, 3, and 4, then the range of g would be the numbers 3, 5, 7, and 9, as shown in the mapping diagram. Note that the symbol E means is a member of or belongs to. To visualize the domain and range, we can look at the graph of the function, and the graph of g of x is shown here. For a domain of all the numbers from 1 to 4, not including 4, we see that the range is all the numbers from 3 to 9, but not including 9. The graph of g reinforces the fact that g is a one-to-one function, as every output value comes from a single input value. Note that on the graph, a coloured in circle includes that value, but an empty circle does not include that value. To draw the graph of the function on your calculator, from the main menu, if you select Graph, then scroll up and press F2, followed by F1 to delete any previous equation, we can then type in the equation. So in this case it's 2, and then pressing the x variable button, plus 1, and then pressing execute. Then pressing F6 to draw the graph. To draw the graph of the function f on the calculator, I press exit to get back to the main menu and scroll up, and again press F2 and F1 to delete the equation. I can now input the function f. So pressing the x variable button, followed by the squared button, and then plus 3. And pressing execute to enter the equation, and pressing F6 to draw the graph. Again, the graph reinforces that f is a many-to-one function. We see that the output value of 19 is mapped from both -4 and 4. And we see that for a domain of all the numbers from -4 to 4, then the range is all the numbers from 3 to 19. In part A of this question, we're asked to find f of 5. So we simply replace x with 5. Performing the calculation gives -8. So f of 5 is equal to -8. In part B, we're asked to find the value of x such that f of x is equal to 25. This is asking what input value into the function f produces an output value of 25. We can find the value of x by writing an equation, equating the function to 25. And we can either solve the equation algebraically, given x equals -6, or we can use solver on the calculator. So from the main menu, if we select equation, and then press F3 for solver, and F2 to delete any previous formula, and F1 to confirm that deletion. Typing in the equation to solve, so that's 25, and then shift to get down to the equals, and 7, take away 3, and pressing the X variable button. Pressing execute to enter the equation, and noting that the number next to X is not the solution to the equation as we haven't pressed solve yet. Pressing F6 to solve the equation gives x equals -6, as before. So if f of x equals 25, then x has to equal -6. In this question, the graph of f is shown, and we're asked to first calculate f of -3. So if we identify -3 on the x-axis, and then draw a vertical line to the graph and a horizontal line across to the y-axis, we see that an input value of -3 gives an output value of 2. So f of -3 is equal to 2. To find f of 2, if we identify 2 on the x-axis, and as the graph goes through this point, we simply draw a horizontal line to the y-axis. So an input value of 2 gives an output value of 0, or f of 2 is equal to 0. In part B, to find the value of x such that f of x is equal to -2, we identify -2 on the y-axis, and then draw a horizontal line to the graph, and a vertical line back to the x-axis. We see that if f of x equals -2, then x has to equal -4. In this question, the graph of the function g is shown alongside, and in part A, to find g of 4, we identify 4 on the x-axis and then draw a vertical line to the graph and a horizontal line to the y-axis. We see that g of 4 is equal to 2. In part B, to find the value of x such that g of x does not exist, we need to identify the value of x that cannot be mapped. If we draw a vertical line at x equals 2, we see that it does not meet the graph. So when x equals 2, no output value exists. And we say g of x does not exist.